Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope that all of you are doing fine and staying safe. Today, our topic is going to be bit streaming. Now, I'm sure that you have gone through all the previous videos and you are doing your worksheets. Today, another worksheet about this lecture is also going to be uploaded in your Google Classroom. Be sure to go through that and attempt and submit that worksheet back on the Google Classroom. So bit streaming. A bit stream is actually a continuous flow of bits over a communication path. Whenever we want to play a video, that video might be stored in form of bytes, but those bytes are actually transferred continuously to the computer, client computer, which need to play the video. That continuous transfer of bits from the media server to the client computer is called bit stream. Wherever the media file is stored, or if the media file is being played live, that file is actually compressed, encoded in any compression format, for example MP4, and then it is continuously transferred bit by bit, second by second, frame by frame to the client computer, and that continuous transfer of bit is called bit stream. First, we need to look at the type of bit streaming. As I was talking about the live bit streaming, also called the real-time bit streaming. You might have watched a lot of sports events online. So as the match is happening, you are able to see that online on your web browser. So the data is being recorded and compressed live. Data is being created and it is being played as it is being created. The data is being played as it is being created. So in the live bit streaming, as you know that there are no pauses or rewinds. You're actually getting the media live, and as soon as the data is played, the previous data which has been played is discarded and you receive the next live event transmission. In the real-time bit streaming, the latency means the delay is always prioritized over quality. Means we don't want our video to lag, we don't want our video to stop, so we are going to compromise over quality. And if the internet connection is not strong enough, if there are some other issues, excuse me. Okay, I think there was a little instability in the internet, but we are back. So I was saying that in the real-time bit streaming or the live bit streaming, the latency is prioritized over quality. Means if we don't have a strong internet connection, if there are some problem with the internet or anything else, we are going to reduce the quality of the video. So the size of the video is going to be less, means we are going to reduce the quality of the video, but we don't want the delay in the video. So delay is prioritized over quality. We are going to compromise quality to reduce the delay. In the streaming sites that you use nowadays, for example, YouTube, if you are having a less powerful internet connection, less bandwidth internet connection, what happens is that what happens is that it automatically reduces the quality of the video so that the smaller video can be played on the slower internet. If the data is it cannot be reliably streamed at the current bit rate, the lower bit rate and quality will be used. As I was telling you, as the internet connection is not having enough bandwidth, the web browser is automatically be transferred to a lower quality video so it can be easily streamed. The uses of the real-time bit streaming, first of all, you can do the live sports broadcast, online gaming, financial data. You have seen that in the stock markets, the value of the stocks are actually updated in real time. The stocks are actually, the stock is actually changing its worth, and as it is changing its worth, it is being displayed in the stock market screen. The weather data is also streamed in real time. All the changes in weather are updated as they are happening, as they are recorded. There are live streaming services, for example, Twitch, where you can make your own streaming channel and start streaming the videos. And then we have the on-demand bit streaming. The on-demand bit streaming is opposite to the live. In this kind of bit streaming, the data is actually stored in some media server, and the user actually goes to the media server and requests some specific file to be played. And that file is actually transferred from the media server. Sorry for the delay. And that file is actually transferred from the media server to the web client, and then it is played. How that happens? That when a client is requesting the file to be played, a buffer is created in the client's memory. A buffer is a temporary allocated area of memory which will start to receive the bits, the data of the video file. As soon as the buffer starts filling up, the video will start being played. And then the data will keep coming into the buffer, and from the buffer it will keep playing. You might have experienced that if there is a delay in the download, if there is a lag in internet connection, that uh, you are given a message that the video is buffering, means the bits are being downloaded into your RAM buffer. In the on-demand bit streaming, the data integrity is prioritized over latency. Means we want to stream the data in the quality we want, in the quality that we have fixed, and we can wait. Means the quality is prioritized over delay. We want the quality, and for that quality, we are willing to wait. The video will download in the quality, and then we can play it. In the on-demand bit streaming, if there is insufficient bandwidth, as I was telling you earlier, the buffering will happen. The video will start to download in the buffer, and when the buffer has sufficient data to play, then it will start playing. In the on-demand bit streaming, the media playback, the music streaming, and the video streaming such as YouTube and other sites can be used as examples. This is actually the flow diagram of the on-demand bit streaming. You can see that media server is sending the data to this buffer over here. This buffer is being created in your main memory. This buffer has these two areas. One is the low watermark and the other is high watermark. The purpose of this, when the buffer start to fill up till high watermark, the video will stop downloading and the internet connection can be used for other purposes. And then as soon as the video reach then the buffer will start to transfer the data to the media player and the video is being played. So as soon as the data in the buffer is going to reach the low water mark, the video is going to start downloading again, so that the user don't face the delays. So the buffer is a temporary area created in the main memory to receive the data from the media player. It has the high watermark and low watermark. When the data flow fills up the buffer till the high watermark, the internet connection is released, the video stops downloading, and as soon as the buffer reaches the low watermark, because the data will go to the media player and will be played, so the buffer will reach the low watermark, the video will start to be downloaded again from the media server. This is actually quite a simple topic as compared to the previous and the coming ones that we are going to discuss. Remember that you have to do the questions like storage calculation. The storage calculation of this can be done if you know how many bits are coming into your buffer and how many bits are going out of your buffer. If, for example, your incoming bandwidth is 100 bits per second and your media player, which is playing the video, the bit rate over there in the playing media player is 200 bits per second, so your net gain will be negative 100. So then your video will be lagging, you will be actually having the delay, video will go to buffering, and then it will be played from there. Now let's move on to the question answer session. There is a practice worksheet about this. Remember to solve that as well. Thank you very much.